What's up, everybody? I'm Matt Gary, and on this episode of Coding with the Fours, we're going to go over the open-close principle. We'll figure out what it is and how to actually implement it in both Apex and JavaScript. All right, everybody. Welcome to the third episode of this solid design principle tutorial series that I'm putting together. Today we are going to go over the second principle in the solid design principles, the open-close principle. We're going to figure out what it is, why it's useful, and we'll go over an example in both Apex and in JavaScript. So let's get to it. What is the open-close principle? The open-close principle, the definition that you will see out there, is a software artifact should be open for extension but closed for modification, right? So what that actually means is, say you build some piece of software, or let's just keep it simple. Say you build in Salesforce anyway, a Lightning Web Component, some custom UI, right? And that Lightning Web Component has been very useful for 3 or 4 months. But now the business is coming to you and they are saying, hey, Matt, I want to be able to change this Lightning Web Component to have a brand new feature on it. Right now, the Lightning Web Component displays opportunities, but we also want to make it so that you can download those opportunities in an Excel document or something like that, right? Who knows? What you would hope is that all you would need to do is extend the functionality of your Lightning Web Component and not have to modify a bunch of the logic that feeds the data to that Lightning Web Component to actually display, the opportunities, right? If the ask for, those opportunities to be able to be downloaded on the Lightning Web Component into an Excel document is an enormous overhaul, not just, because you're creating something new, but because you have to go back to your old code and rewrite the vast majority of it, then your old code, in all likelihood, does not abide by the open-close principle. So, and that typically looks like a controller that has tons of service class logic in it. So a controller that has tons of business logic directly in it that's not reusable. It's intertwined with other code that makes it very difficult to work with. So So we'll go over an example of some code that doesn't abide by the open-close principle, and then we'll rewrite it here in just a little bit so that it does abide by the open-close principle. As far as why this is useful, it's useful because the business that you are building, it doesn't really matter whether you're working at a big business or a little business or your own business, right? Maybe you're building your Salesforce instance for yourself. Who knows? Your business is going to change. You are going to need to create new things. And if it is painful or borderline impossible to change your code to be able to adapt to those new needs of your users, well, it's going to be a pain for you. It's not going to look good that you built your code in a way that's not flexible to change for the future. And, you're going to have some very disappointed users, which will lead to probably considerably lower adoption rate, a want, or maybe even at least they think, a need to move off of the Salesforce platform onto another one. There's a bunch of things that could happen. If you don't design your code so that it's easily extendable to be able to have the new functionality that is needed when it is needed, then there's just a ton of downside to that, right? You want to strive to make sure that this open-close principle is at the very least implemented in the code that you write. Very super useful. Makes you look great if you can build your code this way, and then you can iterate on your code pretty quick. It doesn't take you months or years just to update something like adding an Excel document download. Yeah, it's easier for you as a developer to upkeep it and deal with it too. So, all right. So we've gone over the what is open-close principle. We've gone over why it's useful. Next, let's go over a bad example of some code and rewrite it in Apex so that it actually abides by the open-close principle, so we see the incredible value that we get out of it. All right, guys, real quick, before we get into the code, let's just take a quick look at the application that we'll be modifying. So I've created this nice little lead map that basically takes every lead in my system that has a address that's completely filled out. So it's got, like a street, postal code, state, city, all that kind of stuff, and plots it on this map. And then people can click on it, and it's all fun and thrilling and exciting. Cool. So it looks like it works, and it's all good, and it's beautiful and all that. But let's take a look at the code and figure out what problems we might encounter with its current setup. So if we come over here, we can take a look at the map itself, the Lightning Web Component. You can see that the Lightning Web Component anyway is pretty simple. There's not a whole lot to it. I basically just have a Lightning map. I pass it in some map markers and display it. So far, so good with the Lightning Web Component anyway. But if we come over here to our open-closed bad example class, which is the controller currently for this one, for the Lightning Web Component, we can see that we just have a method in here that says get leads for map, and it queries for our leads, and then it conforms our leads to the way that they need to be conformed so that they can actually be put on that map. And then there's an inner class in here called map marker to help with everything. And right now this works out great, right? It works out fine because we only need to put leads on that map, and we don't need to reuse this map anyway or anything like that. But here comes the problem. The business ends up absolutely loving the map. And they say, hey, you know what? Can we have that same map on contacts? And, can we potentially also maybe put like a data table below the map so that we have a nice looking list of everything that's easy to look through? And the answer to that is, yeah, of course. No big deal. But then you have to ask yourself the question, what do I do for this, right? Because the easy answer is you could technically reuse this component potentially, and here you could get the API or import API and grab your object API name, and then you could pass that API name into the controller method, and then in here you could take like a string object name, and you could do something crazy like if object name equals lead, and then wrap all this in the lead stuff. And anyway, you do that and it gets ugly, right? First they want it on contact, then they want it on campaign member, then they want it on another custom object you have, and it just goes on and on and on. And this looks horrible. And of course, two things. Number one, the code gets super difficult to maintain with this method. And you are violating the open-close principle, right? Because you're not just extending the capabilities of this class anymore. You're definitely modifying the methods within it, right? You're modifying this method heavily. Now, the other thing that you might be thinking is, well, you could just create a brand new component and then you just duplicate what we have here, except for you don't pass in the API name and blah, 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 blah. Well, sure, I guess, but at that point, you know, these are virtually identical components, right? If you made one for contact and one for lead, they're basically identical components, and the only difference would be that you'd call a different controller to prep the data for you, right? So now you have a different problem, which again kind of violates the purpose of the open-close principle, which one of the biggest purposes of the open-close principle is not to replicate your code a whole bunch. But you also now have two different versions of essentially the same thing to maintain in your code base, which makes it harder for you to deal with, makes it harder for you to iterate on these components, and it just makes it a bigger pain overall. So the question is then, how do you deal with this? How do you make a situation like this abide by the open-close principle and make it so that you don't have to modify this controller and you hardly have to do anything to pre-existing code for this Lightning Web Component, right? How do we deal with it? And it's a little simpler than I think you might think. And if you watched the last video or the previous two videos in this series, you're probably going to recognize some similar things going on. By the way, before I get started on what we're about to build next, if you haven't looked at the interface video that I've created, please go check that out. I'll link it up above and I'll put it in the description below. But definitely go check out the interface video at the very least. And if you haven't watched the other two videos in this series, definitely go back, check them out, or else you might be a little lost when I start building this code here in a second. Okay? Okay, you've been warned. All right, so prep yourself. All right, so what we're going to do is leverage the power of interfaces to do what's called dependency inversion, which happens to be the fifth principle in the solid design principles. So I said it's my favorite principle, and it's because it is basically the backbone of a whole lot of stuff. So let's figure out how to actually do this, right? The first thing that we're going to want to do is actually create our interface. And so we're going to come up here, and I'm going to create an interface called, I don't know, display wrapper interface or something. You could also, I'm going to capitalize this, you could also call it like UI wrapper interface or whatever else. And we're going to delete this and put the word interface in here. And we're just going to create our method signatures. And our method signatures are going to be list of S objects, and we'll say get records because we want to be able to get the records to display, so we want to be able to query for them in whatever format. And object wrap records for UI, and we're probably going to want to pass this a list of S objects, and we'll call it S object list. Okay. Or maybe records. We'll call them records. S object records. Cool. All right, so we've got these two method signatures in our interface. So anything that implements this interface is going to have to implement these methods, right? Which is great. And we'll see why it's great here in a second. The next thing that we are going to do are actually create our implementations of each of these basically different varieties of prepping data for a map, right? Actually, the first thing that we'll do, or that we would normally do, is create this map marker class, because we don't actually want this to be an inner class of a controller, at least in our case. So I'm gonna rip this out, and I have already created a map marker class. I believe I have, yep. Just because with all these examples I do them ahead of time, just to hopefully waste your time a little less of your time. So I'm gonna break out this map marker class so that it no longer lives in here, and so that I can use it in all of the like concrete implementations of this boy, I can't find my words today, this map marker wrapping situation that we've got going on here. All right, so we've got our map marker class broken out. We've got our interface made. Let's make an implementation of this for both the contact and the lead object. So let's go up to classes. We'll make another Apex class, and we'll call this map marker contact impl. Impl stands for implementation. I like to basically name my concrete implementations as an well, you see the difference between a concrete implementation and a non-concrete implementation in just a second, so I'll compare and contrast them here in just a moment. And we're going to have this one implement the display wrapper interface that we just made, and we'll grab these method signatures over here, drop them in here, and add an implementation for them both. So I'm gonna make them both public. All right, so now we have this map marker contact implementation, and it implements this display wrapper interface, and we want to be able to get records specific to the contact. And now, since I've already done this once, I'm not going to waste our time too much. I'm just gonna drop in the query that we would want to put here. So for me, let me zoom in a bit. I want to be able to query for a bunch of the mailing, postal, a bunch of the different fields. Basically, most of them are mailing address related, and then the name and the description. And then I want to make sure that none of my mailing address fields are empty, right? They're not null. And then the second thing I want to do is actually build my map marker for my contact object, right? So basically I want to pull in the mailing country, the mailing postal code, mailing street, mailing city, blah, 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 right? Which is different from the lead, which needs country, regular country, city, postal code, street. The field names are very different. And that's really it, right? I've got my map marker contact implementation set up. I know how to get the records. I'm just querying for them the way I want to, and I can wrap the records for our UI display for them. Cool. So I've got that set up for the contact object now. Now I need to do the same thing for the lead object. So we're just going to create another class called map marker lead impl. And we're also going to have this class implement display wrapper interface. And I'm not going to waste your time on this one too much either. I'm going to pull over those methods and just talk to you about them. So basically we're, yet again, just like in the contact one, implementing the get records and the wrap records for UI methods, right? So we've got those both in there. And we are querying for the lead records in the way that we want to query for lead records. and we are wrapping the lead records in the way that we need to actually wrap them, right? So far, so good. Pretty simple, pretty straightforward. Now we need a kind of what I like to refer to as the middleman, or in this case, it's the service class that this controller is actually going to call, right? So that it doesn't have any reference to these concrete implementations. We don't want that at all in our controllers. We don't want the controllers to know that this class exists or that this class exists. We don't want that, because at that point we have made it so our controllers are not flexible for future changes, and it's a pain. It's more of a pain to upkeep them, and they're not as dynamic and flexible. And we'll definitely see that here in just a second. So basically what we're going to end up doing is creating one more class, and we will call it the let's see, what should we call this? We'll call it the UI UI wrapper service, and from here we are going to technically implement both of these methods, but we're not going to do it in the same way. Where am I here? There we go. So we need this get records method, and we need the wrap records for UI method, but they aren't going to follow the same implementation guidelines. So we're not going to say implements display wrapper interface, and you'll see why here in just a second. So we've got both of these methods. We'll fill them out in just a minute, but then the last thing that we need to do is declare a map. And this map is going to act as our way to dynamically change which class we are calling at any given time. So we are going to say, let's see, object and UI type to wrapper impl, and we'll say equals new map string type and now that I've done this wrong, now that we've got this set up, we need to actually map an object in a UI to a wrapper implementation. So what we'll end up doing is saying, all right, if we have a map marker for, or actually the contact object that needs a map marker UI, then we'll map that to the map markers map marker contact impl class. And if we have a lead map marker, then we will map this to the map marker lead impl class, just like that. And so now, now what we'll be able to do is pass into these methods here the object type and the UI type that we want to render, and then it will get records based on the UI and the contact type, or in the object type that we have, and then it'll wrap them as well and then push them back out to the Lightning Web Component, like we'll see here in just a second. So the first thing that this method actually needs is to receive an object type, and it needs to receive a UI type. And then we will initialize our classes here through the use of this map and through the use of the interface that they both implement. So down here, what we'll end up doing is saying what was the name of our display wrapper interface? Say display wrapper interface new wrapper interface equals new object and UI type wrapper impl dot get object type plus UI type dot new instance. And we'll need to cast this because it's not like the compiler is going to immediately know that this map is going to return to us a type of display wrapper interface, right? The compiler's smart, but it's not that smart. And from here, because we know that the display wrapper interface must implement the get records and the wrap records for UI. In here, we can say dot get records and just return this, right? So I should have told you to hang with me because that was a lot of stuff, a lot of confusing stuff. But let's just go over what we've done in the last couple minutes here. So we've created this interface. The interface acts as our contract between these classes that says, hey, classes, you've got to implement the getRecords method, and you've got to implement this wrapRecords for UI method, right? So we've got these two classes that both abide by this interface's rules. And then over here we have this UI wrapper service that uses a map to kind of act as to leverage the factory pattern. And if you don't know what the factory pattern is, I have a tutorial over that as well. So I'll link it above potentially and in the description for sure. And definitely go check that out if the factory pattern is a new concept to you. So then we're creating this map to kind of leverage the factory pattern to basically dynamically say, hey, based on the object type and the UI type that we're wanting to get data for, initialize a class and call the getRecords method for that specific class implementation. So if I end up getting a an object type of contact and a UI type of map marker, then it's going to, even though it says down here I'm creating an instance of display wrapper interface, what it's really creating is an instance of this class, right? And it is using the getRecords method from within this class here. Okay? It's kind of confusing, but again, if you look at the interface tutorial that I have created, that it goes in much more detail. So we're gonna go and do basically the exact same thing below here. And the only thing is we still need to pass in the UI type. And the difference here is that we don't have the string object type, but that is okay. We can just do get as object type over here. Let's move this over. And I believe I need just an empty string to actually concatenate these. And then it'll still work just like above. But we want, in this case, to do wrap records for UI, and we need to pass in sObjectRecords. All right. Cool. So we've done a lot of things here. We've broken these out into their own implementations. The lead version of, creating map markers, and a contact version of creating map markers. And then we have the kind of abstracted service that calls both of these implementations based on what we pass it. And you might be thinking, well, hey, Matt, we're kind of replicating code in these two classes. Well, why don't we just merge them together? And technically, you are correct. And technically, you could merge them together. You could abstract this a little more. You could use some custom metadata, and you could merge this down even further into one class, potentially. But the one thing I would be a bit wary of if you do that is that these could pretty drastically diverge from each other at some point in the future. And it might not work as well if they're merged together. At least, of course I closed that. At least in this case, they're both separated. So if you needed a new implementation, you're not going to have to update these, right? So say, for instance, in the future you need a campaign member version of this. You'll just implement a new class or create a new class that does the exact same thing but for campaign members. Whereas for this other example back over here, there's not as clean of a way, right? This controller is basically going to house everything forever and grow and grow and grow and grow and grow and become unmaintainable at a certain point if, you know, it expands to different objects and all that. So this is just a little cleaner way to keep it updated and also technically abide by the open close principle, because we're never going to really have to go back and, you know, if somebody says, hey, I want the campaign member stuff, I want to put this map on the campaign members now, you're not going to have to go into this code at all, right? You're not, after we're done updating things in just a second, going to have to even go back into the controller to update anything. The only thing you'll end up doing is creating a new implementation class, adding that implementation class to the map by saying, you know, campaign member marker, and then mapping it to that new class that you created there. So a lot less work. So last thing we're going to do, I'm just going to create a new controller because I hate the name of the old one, and we'll call it the LWC map controller or something like that. And within here, instead of naming it whatever we named it before, which is get leads from map, let's make it get data for UI or something like that. And I needed to do a whole lot more than this. So we'll say public list of object, and this also needs to be static because we need to make it Aura enabled, and we will pass in an object API name. And then what we'll do is we will call our UI wrapper service, which I would actually prefer this to be public static. I think that service classes are a little easier and better to deal with when you make them static, house static methods, but that's just my personal preference. I don't know that there's any right or wrong there. And then let's go with UI wrapper service dot get records, and we'll pass in our object API name and the in this case we're going to get our what did we call this over here? Man, I'm really not on it tonight. Map marker. That's the UI type that we're going to want to pass in. And then after we get our list of S objects in return here, we're going to do wrapper service dot wrap records for UI, send it the object list, and then send it map marker, which at this point should definitely be a private static variable in this class or somewhere. It should not be hard typed in here twice. And then we will just return this to the UI, which is pretty cool. So this will literally never change. I could drop this on multiple objects, dynamically figure out what the object API name is, and it will still do its job, which is pretty cool, I think. Anyway, and so we could actually let's do this a little better. String UI type. Then we've got even less to do here in just a second. So let's go back now that we have this set up, and we will go to our LWC map, and we'll change this Apex class import to import our LWC map controller and the getDataForUI method that we just created. So that guy right there. And then down here, let's also just say get UI data controller, and let's call that down here, and we'll say if we need to pass in our variables, this dot object API name and map markers, and let's see what I name these variable names: object API name and UI type. All right, what mistake did I make? Oh, I forgot to actually put the brackets around these. All right, so that should really be it, right? If I save this, now it might not save them all right, and I might have to go back a couple times and save them in order, which is always fun. So let's do that. I'll go back here. I'll save this display wrapper interface first. Then I'll save this implementation. I'll save this implementation. This one. Oh, I've broken something. Variable does not exist. Object in UI type to wrapper. Oh, yeah, that makes sense. Private static. Okay, and we'll save this controller. And last but not least, we will save our Lightning Web Component. So when you have a bunch of dependencies like that, you often when you try to save them all at the same time down to your Salesforce instance, unless you get everything perfect, it's not going to go well. And you should just save them in the order in which they should be saved. So you'd save your interface first, then the things that implement them, and then the UI wrapper service here. All right, I'm not going to go too deep into that. Now, hopefully, if I didn't screw this up, which is very likely, then I'll be able to reload this page and the map will still work. And I've done something wrong, as per usual. So let's just figure out what that something is. We can open our dev console and see what's going on. Maybe. Oh, or the dev console's gonna glitch out on me here. Hang on. All right. One more shot and we'll see what's going on. So I did something to attempt to dereference a null object on UI wrapper service line 12 get records. Cool. So let's just go check this out and figure out what I did wrong here. Object type, UI type, contact, lead, map marker, map marker. Am I not passing something in? Right. that's it. Something nice and dumb. I put map markers instead of map marker. This is exactly why you should make these like variables that are constants at the top of your class or something, so that you don't do dumb things like Matt. All right, so let's give this another shot and hope that it actually works. And it does. Cool. So we've got our leads popping into the map. Now, what if we wanted to just test that the contacts will do the same thing? Well, let's come over here and just for the sake of it, let's just change this temporarily to contact. And we'll hit save. And so now, right, we're passing in contact to the controller, which passes it to the wrapper, and then we should get the contact implementation to run. And hopefully I've got contacts with addresses. It's not like I had looked into that, so smart. It's looking like maybe there's nothing around. List index out of bounds. So chances are pretty high that I've got nothing going on here. Wrap records for UI, line 16. So yeah, it looks like I've got nothing coming back, and that makes a whole lot of sense because I probably have no contacts. But let's just go make a contact just so that we can verify that this actually works. So we'll go over here to JigPig, good old JigPig, and we'll fill out his address wherever it actually is. Where are you? Address, mailing address. We'll just say 123 Taco Street. Actually, you know what? We'll do some old house of mine. All right, and hit save. And we'll see now, hopefully, if we go back to our lead object where this map exists, that something does indeed render. And it does. Cool. So we've got our one contact with an address showing up. Wild. All right, so everything is working as expected. Now, you know, this gives us an enormous amount of flexibility too. One of the things that I mentioned before is, you know, what if we want to drop in a data table right below this map or something? Well, now with what we've set up here, right, you can send in a new UI type. So I could send in, instead of map marker, I want it to be you know, a data table type. I could create a new implementation that housed my maybe it'd be like data table contact or data table lead impl, and then create the data type that I need, the wrapper object that I need, and send it back, right? And I'd only need to call this. And so you can see the flexibility of this controller here just becomes enormous, right? I could, with this get data for UI method here, generate data types, or, you know, data that will work with a data table, that could work with a lightning map, that could work with potentially a record edit form. Who knows, right? And all I'm going to have to do is extend the capabilities. I'm not going to have to go back and edit anything. Like, I don't have to edit this controller. I won't have to hardly edit anything in this Lightning Web Component here. I just have to add a data table and add a method to grab stuff specifically for the UI type of data table. And so the basically effort to be able to extend this component goes way down, right? Like way down. And if I ever need to change something, it's super easy. You know, if I'm if a user has a problem with the map on the lead object, well, hey, guess what? Not a big deal at all. I will just go update the lead implementation here, and we've fixed our problem. And now, I can drop this if I just to display the power of this setup here. I can drop this on any object, and it'll work great, right? So let me just save this. And if I went to the contact object, as long as it has an implementation, right? As long as the object has an implementation in this wrapper service, I can just go to good old JigPig here, come down to edit page, and I can drop in my LWC map, and it's going to figure out its life and drop in the contact stuff, right? So if I save this on my horrifyingly ugly contact layout now, and I come back here on contact, it's going to find the contact stuff, and if I went back to my leads, it's going to find my lead stuff, which is different, right? Pretty cool. I have to do nothing, literally nothing, to get this to work on either object now, which is pretty awesome. All right, so we've gone over the Apex stuff. Let's just go over a quick example in JavaScript. Okay, so let's check out this JavaScript example. It's going to be quite a bit simpler than the other one. So basically, we've got this open-close bad example version of a Lightning Web Component. And effectively what we're doing is we are just saying, if we're on a contact object, let's set the contact message. If we're on the lead object, let's set the lead message. And potentially this could expand, much like our other use case. It could expand to the campaign member object, custom objects, to whoever, who knows. I mean, this is just an example and a random one that is not as exciting as the other one, but I think you get the point here. If I need to expand this to the campaign member object, well, then I absolutely have to modify this, at least in its current state. I can't just extend it, so I'd have to say something like else if this dot object API name equals campaign member, or whatever the object is, I forget these days, this dot set campaign member message, and then I'd have to go create another method down here that says set campaign message, and then do this dot message equals Django Fet or something, who knows. And as you can see, just like with the single responsibility principle last week, this can get out of hand, right? Like, you're now having to modify your LWC JavaScript controller every single time that you have a new object that you're using here. And this is a simple example, but what happens if for the lead object you do like 20 different unique operations, and for the contact object you do another 20 different, you call 20 different methods for it, and the campaign member you call another 20 different methods for it? Well, this class becomes unruly. It becomes out of control, and you're absolutely for sure modifying it constantly, right? You are not abiding by the open-close principle. You're not extending it. You're just constantly modifying this class. So how do you actually deal with this then? What we're going to end up doing, where are you? There it is. We're going to create a new JavaScript file, and we'll call this the, object service class or something. And the object service class is just going to, for now, have a set message method. And we'll just say set message, and we'll get an object type, and we'll just start that same chain of events. Unfortunately, in JavaScript, there's not much you can do to get out of the realm of if statements unless you use TypeScript, which is kind of tricky in Salesforce. I'm going to delete these because this is going to look a little different here. And what we'll do is say, let's see, class type. And we need to create a bunch of classes to deal with what comes next. I'm going to just delete campaign member so that we don't waste too much time on this. So the next thing that we're going to need to do is create yet another JavaScript file. And we'll call this contact object service, or actually a better way to name this is object service contact impl. And so in here, we'll also want to implement this set message. And that'll be it. And, you know, if you didn't know, there's no such thing as interfaces. There's no such thing as strongly typed anything in JavaScript, so you can't like force something to abide by a set of rules like you can in Apex with interfaces. But because JavaScript is a loosely typed language, you can just basically haphazardly pass whatever object or class type you want around and call its method. So as long as every class has the same method names, then it will work the same way as a class that implements an interface in Apex, which we'll see here in just a second. So we're going to create one more that's called object service lead impl. And this one is going to have another set message thing here. And we'll just have this return a message. Return, I'm a lead. And this one will return, I'm a contact. And if we come back over here to the object service class now, what we can do is say class or this dot class type equals new object service contact impl. And you'll notice, man, my nose is killing me. You'll notice that this is importing this class that I just made. So because this file is local to my Lightning Web Component folder here, it's going to use this dot notation to say, all right, I exist in the same directory, but grab this JavaScript file and import it for me, please. If you created these classes in a different, Lightning Web Component, instead of using the dot, you would use a C. But it's going to automatically import this for me, so don't forget to do that if you're using Visual Studio Code. I don't think it auto-imports this stuff for you. And then this dot class type equals new object service lead impl, right? And the last thing that we will end up doing is saying the last thing that we end up doing is actually not here yet. We need to create a factory so that we can implement the factory pattern, much like we did in Apex, right? It's just a little different in JavaScript. So we're going to create an, well, what is this called? Object service factory. Boom. And let's set this guy up. So we are going to also have a class type up here, and we'll create a constructor. If you didn't know, this is just like a constructor in Apex, but in JavaScript, you don't use the name of the class. Instead, you just use the keyword constructor. And we'll say, we'll pass in class type here. And we'll say this dot class type equals class type. And we will do the set message yet again. And we will say this return this dot class type dot set message, just like that. And this one should now be able to call. Make sure I don't mess this up. Constant. What am I doing here? Constant. We'll just say message. Actually, constant service factory. Since I can't seem to think of names today, equals new object service factory. We'll pass in this dot class type, and then we'll say service factory dot set message, and we will have this return a message as well. And if we go back over here to our JavaScript controller, now instead of doing all this stuff and having all these things in here, we can delete all this, and when we call, we can just instead call our object service class here to actually get our message. So we'll say, make sure I actually did this right. Yep, okay. We'll say constant object service equals new object service, and then we'll say object service dot set message object API name, and there you go. You can get everything done from right there. And now that all this stuff is set up, let's go over a couple things, I suppose. Number one, now this controller for your Lightning Web Component does not have to change, at least for setting messages, right? Now this is all handled by a message, an object service class that sets messages for you. So you'll send in this, your object type into here, which will then determine which object-specific service class it should create, whether it's a contact one or a lead one, and then those specific contact or object services will actually hold the method or methods for those respective objects, and then you're only having to go in and update, your existing object-specific class, as opposed to your controller that would otherwise house everything, right? And you're now abiding by that open-close principle, because if you needed to extend this to campaign member now, are you, modifying existing code? No, you're not. You're now extending the capabilities of the existing code, which is very different, right? You're not having to modify the existing stuff. There's no risk of you accidentally breaking something crazy. The only thing that you're going to have to do is update this one class right here to say, if this is a campaign member, then call the campaign member implementation that I'm creating. And then I'm going to create a brand new class that is the implementation for a campaign member's set message or whatever else could potentially be housed in there. So hopefully that makes sense. It's very similar concept to the last one, or to the Apex example. It's just a little different because of the rules around JavaScript, right? The way that JavaScript works is different because it's not a strongly typed language like Apex. So I think this video is probably very long, and we've probably covered enough, and hopefully I did it at least pretty good. I hope anyway. So let's just recap what we went over, since it's been quite a long video. Number one, we went over why the open-close principle is useful and when you should use it. We also went over an example of the open-close principle in Apex where we saw, if we design our code right, you don't have to edit or modify really hardly anything in the existing code, because, right, as we could see in the UI wrapper service, if we ever needed to extend this to, say, campaign member or a custom object, the only code that we're ever going to have to change is this right here, where we'd say something like campaign member map marker or something, and then map it to a class, and then we would create a brand new class for the campaign member. And we do the same thing with the JavaScript example that we just made. If we did campaign member here, then we'd only have to update this little portion of code right here, nothing else, and then we would create a new campaign member class and use it, right? And that's extremely different from having to do what we did in the beginning here in the bad example, where we could potentially have spanning if statements and tons of code all in the same place, and it just gets more and more dangerous and more confusing and huge the further along you get into an application's lifecycle, right? So the more features you had in here, the crazier and crazier it might get. So hopefully what we went over illustrates the usefulness and the power of the open-close principle. Basically, makes your code easier to deal with, makes it easier to add features to without being worried about potentially breaking existing ones. And yeah, overall, just a good thing to attempt to do. It's not always achievable, but typically it is. So, all right, that ought to do it. If you like this video, make sure to subscribe, comment, actually like it, and hit the bell so you get the next update for the next video. Yeah, hopefully this was helpful, and I'll see you all next time.